In this video, we want to write our first application that uses the actor model of parallelism. Now, the library that's used for actors in Scala is the Akka library. And so we need to start off by going to akka.io, and we need to download the Akka library. Once we have that downloaded, we can make a nice directory for it. Actually, I'm going to go out on a limb. Let's downloads. We need to unzip the file that we got. And you'll see that everything's being put in this directory Akka-2.4.1. So I'm going to move that directory up a level so it's in my main directory. The Akka website has documentation. You can find things like the Scala API for Akka, and as you should be well aware at this point, it's helpful to be able to go through the API and find things. We're going to go through and talk about the various ways that you can program stuff inside of Akka, but it's helpful to have the API available for things that we might not hit in detail. So we're going to go ahead and we're going to create a new Scala app, and I'm actually just going to call it Simple Actor. Now, because we're using the Akka libraries here, we need to add that to our build path. So I'm going to go ahead, I'll select Add External Jar, and go into Akka lib. There's a Scala library. I'll add in. Let's go look at what else we have inside of the lib directory. So inside of Akka, there's a number of these others. We do not need all of these, but it's quite possible we'll need some of them. So we'll come in and we'll add the ones as we need them. Things like the config and the Akka actor are likely to be jar files that we're going to need in order to get things done. So we've extended our app. It turns out that in order to make an actor, we need to create a class that extends actor. Now, a lot of times we might write these in separate files, but I'm just going to keep this nice and compact. Let's refactor this. So the simple actor, I'm going to refactor simple actor example because I actually want to save. I want to call this the simple actor, and it extends actor. Yes. So Scala has an old actor library in it, and it's contained in scala.actors actor. We don't want that one. So I'm going to go ahead and get rid of that, and we're going to add into our build path the actor and that is not the config and the actor. We'll add those in, and now if I do an import, I get an option. It says, did you want the Akka one or the Scala one? The Akka one or the Scala one has been deprecated, and there are a number of reasons for that. It basically made it too easy to do things badly. So we want to use the Akka one, which is an improvement. The Akka library actually sits as a foundation for a whole bunch of things that use parallelism in Scala. Now this is unhappy because it turns out that everything that is an actor needs to define a receive method. And so we're going to define our receive method, and we just set it equal to a partial function. And the partial functions in Scala use curly braces, and we have cases. So whatever patterns we want to match. So I'm going to make this one fairly simple. If we get sent a message that is a string, we're just going to print out that we got a string and say what it was. If we get a message that is an integer, then we'll print line what we got there. Okay, that's a good place to start as far as our messages go and getting them and handling them. Just to illustrate something, let's go ahead and let's also write a normal method inside of here. This will mainly be for illustrative purposes, to show that, well, basically we can't call that, at least not within the system very easily. So that sets up an actor. In order to use Akka, we need to have our classes for our actors. We also have to build something called a system. And I'm going to call our system, system. And to make it, we do actor system. We're going to call the apply method on it. And we have to give our system a name. I'll call this simple system. I'll do an import, and you'll see that was in the Akka actor system. And then we need to create an actor. Now we don't make actors using new. In fact, if you try to do a new simple actor, when you run this, you'll find that you have problems. This will not be happy for us. There we go. So you get a message that says you can't create an instance explicitly using new. So how do you create actors instead? Well, you use them by creating them on either on the system or, as we'll see later, inside of a context inside of a system. So for the system, I can say actor of, and then I have to pass it information about how it's going to build this. And there's a type called props that we can pass in the type that we want to create. So our simple actor, and it's ideal to give our actors names. We only have one actor in this example, so I'm just going to call it simple actor. Let's do an import, so we can import the props there. And we once again have happy code. This happy code runs, but we're not really doing anything. You'll also notice that it doesn't stop because the system has potentially multiple threads, and it's just sitting there waiting to receive messages. How do we send a message to an actor? Well, that's actually fairly simple. You do it with an exclamation point, which we often read as bang. So we're going to say actor bang, and we can send it a message. For example, hi there, or 42. And if I run this, based upon the code that we put inside of our actor, we should say, yep, string, hi there, number 42. That's all expected. To prove this is happening in separate threads, we can put some print statements here in the main thread. So before messages, print line after string. That's not the character I wanted. Print line after int. And then to demonstrate something, I'm actually going to send our actor something completely different. Neither a string nor an int. Print line after care, because that'll help us illustrate some features of this. We can run this, and we get before messages, after string, after int, and then it prints the string hi there and the number 42. So you can tell that this message got sent, but it doesn't actually print until after several of these other things have happened. That's because the actor's code, this receive, is going to happen on a separate thread, and it does not have to happen immediately at the time when any of these messages are sent. It will happen at some point in the future. That message will be queued up, but it does not have to happen immediately. That separate thread could take a while to do it. So we'll come back in the next video. We're going to look at some more aspects of what's going on in this particular application, and then we'll add more complexity to our actor system.